Hey everybody, so in this video we're going to talk about 4.1, which is about the quadratic formula. Okay, so you guys should have seen the quadratic formula before. I will just remind you what it is. Okay, so you can use it for quadratic equations. Okay, but the quadratic equation needs to be in the standard form, ax squared plus bx plus c equals 0. Okay. Okay. So the quadratic formula gives the solutions for this type of equation. Okay. So like I said, you guys should have seen this before. We're going to go over a couple examples of how to use this, and then we will do an example of what else you can do with this formula. Okay, so let's look at an example. Okay, so we're going to solve these using the quadratic formula. Okay, so the first thing we're going to do is decide what the values of a, b, and c are. Okay, so a is the leading coefficient, so in this example a is 1. Okay, b is the coefficient of x, so in this example this is -1/2. Okay, and then c is the constant term, so in this case that's 1 also. Okay, so we're going to write out our solution. This would be x equals opposite of b, so 1/2, okay, plus or minus the square root of -1/2 squared minus 4 times a times c over 2a, which is 1. Okay. All right. And then all that's left to do here is to simplify this. Okay. Okay. So -1/2 squared is 1/4. Okay. Minus 4 over 2. Okay. So then we are going to go ahead and combine these two. Okay. So right now we have 1/2 plus or minus the square root of 1/4 minus 4 over 2. Okay. So we're going to combine these two by making common denominators. Okay, so 1 minus 16 is 15/4. Okay, and then we're going to simplify this. We don't know what the square root of 15 is, so that's going to stay, but we do know what the square root of 4 is, so we'll write this as root 15 over 2. Okay. So now we're going to combine these two because they are of already common denominators. Okay. And then we're going to simplify our complex fraction. Okay. All right. So this is a good example of the type of equation that you could solve with a quadratic formula, okay? Because of the format of the original equation like this, okay, it's not possible really to factor this, okay? It's also not possible to use extraction of roots because we have this x term here, okay? We could use complete the square, but it might be difficult because of the fraction, Okay, so that's really what indicates that this method might be the best method for solving this equation. Okay. Right, this is the fourth method that we've learned to solve quadratic equations. Okay, and you guys will find that in different situations, different ones are the most beneficial. Okay, so we're going to look at another problem like this. Okay. Okay, and this is another instance where people will use the quadratic formula, and that's if you have an equation that's completely symbolic, like this one, okay, and you're trying to isolate a particular variable, okay? So the first thing we're going to do is put this into that standard form, okay? So we're going to put everything on the left with 0 on the right. So we would have 1/2 at squared minus bt plus s equals 0. Okay. And then we're going to determine what our a, b, and c value are. So remember, our variable is t, okay? So everything else is just treated as a number value, okay? So our a value is going to be, it seems kind of funny because there's already an a value here. So our a value from the quadratic formula is going to be 1/2 a, okay? Our b value from the quadratic formula is going to be negative v, okay? And our c value from the quadratic formula is going to be s, okay? So we're going to go ahead and plug this into the formula, okay? So we'll have the opposite of b, which is going to be v, plus or minus the square root of b squared minus 4 times a times c, okay, over 2a. Okay. So now we're going to simplify this. Okay, so here we'll get v squared. Okay. Here 4 times 1/2 is 2. Okay. And then in the denominator here, 2 times 1/2 is 1, so we'll just have a. Okay. There's really no way to simplify this further, so we would just leave our answer in exactly this format. Okay, I know that this seems unusual, but this is something that you would see in a science class. They'll often ask you to take a generic formula and isolate a particular variable. Okay, so this is an example of how you could do that using the quadratic formula. Okay, so those are the kind of solve using the quadratic formula type examples that you can expect to see. Okay, another example I wanted to show you was actually from a previous video. Okay, so remember this example, a tennis ball is thrown into the air. Its height after t seconds is given by this formula. Okay, for what values of t is h of t equal to 0, and what does it mean? Okay, so when we were solving this equation before, okay, we correctly substituted in 0 for h of t, and that gave us this. Okay, and then we're going to divide everything here by -8. Okay, so we're going to divide everything by -8. Okay, so -16 divided by -8 is 2. Okay, 16 divided by -8 is -2. Okay, and 8 divided by -8 is -1. Okay. All right. So now we were trying to solve this last time, and we weren't able to come up with solutions using the method of factoring. Okay, you can see that this does not factor. Okay, it's prime. So we're going to use the quadratic formula. So in this example, a is 2, b is -2, and c is -1. Okay, so we're going to get that t equals 2 plus or minus the square root of negative 2 squared minus 4 times 2 times negative 1, okay, all over 2 times 2, okay. All right, so this is going to give us 2 plus or minus the square root of 4, okay, so we have 4 times 2, which is 8, and this gives us plus 8, okay, over 4. Okay, so here's our exact answer. Okay, and because this is a word problem, we might be interested in an approximate answer. Okay, so we can go ahead and type that into a calculator. Okay, and we can see that t is approximately 1.37. And then the other value for t is going to be negative 0.37. Okay, so those are my two approximate values. Okay. Now, when we're thinking about what this variable stands for, right, t is time. So we're thinking about after the ball is thrown, okay, so this would be 1.37 seconds after it's thrown. This would be 0.37 seconds before it's thrown. So this doesn't really make sense in this situation, okay. So what would our answer be then? Okay. So our numerical answer would be that t is approximately 1.37, okay? And then let's answer the question of what does it mean, okay? So remember, this has two parts. We're going to say what the t value means, okay? So this is time. So after 1.37 seconds, okay? And then let's look at how this all started. Okay, we said h of t was 0. Okay, h of t is the height. So the height of the ball is 0. Okay, now again, when we're answering these types of questions, we don't want to just write the height of the ball is 0. We want to really interpret what that means. Okay, so think about when the height of a ball is 0, right? That would really mean that the ball hits the ground. Okay. All right. So there is an applied example of when it's appropriate to use the quadratic function. Okay. All right. Let's talk about another useful function for the quadratic formula. Okay. So if you look at the formula itself, okay, it looks like this. Okay. Now, this part inside the square root is a special part, okay, and that has its own name. Okay, this part of the formula is called the discriminant, and the reason that we're so interested in this particular part of the formula is because it determines what type of solutions we have. Okay, so we also denote this with D for discriminant. Okay, so if you have that this part is negative, okay, imagine what's happening, right? You have the square root of a negative number, we know that that's what gives us I, okay? So this says that the equation has two complex solutions, okay? Because we're taking the square root of a negative number, we're going to get complex answers, okay? And we even know that they are conjugates, right? Oops, can't spell. Right, so our two solutions are going to be a conjugate pair, okay? Now, if you have a positive number, then this is going to work out really normal, just like the very first example we did in this section. So if you have a positive value, okay, your equation has two real solutions. Okay, you get normal solutions. They might have a square root in them, it might not, okay, but it's going to be two real number solutions. Okay, now the only real question here is what happens when it's exactly 0? Okay, and this is kind of a strange case, right? But if you think about what would happen, if this term isn't here, right, you're only going to get one answer, and that's exactly what happens. You get one real solution. Okay. We often call that a repeated solution. Okay. All right, so let's do an example of using this to decide what type of solution something has. Okay. So we're going to determine the number and type of solutions. When you see type of solutions, what they mean is, are they real solutions or are they complex solutions? Okay. So we're going to look at this equation. Okay. So we're going to look at the discriminant. So this is going to be b squared, so negative 17 squared minus 4 times a times c. Okay. So 17 squared is 289. Okay. And then we'll have 12 times 26, which is 312. Okay, so our final value for the discriminant is going to be negative 23. Okay, so we know that the discriminant is a negative number. Okay, this tells us that there are two complex solutions. Okay, it doesn't actually tell us what the solutions are, it just tells us how many there are, right, which is really 1 or 2, okay, and then it says if they are real or complex. Okay. All right, I hope this was a good review of how to use the quadratic formula and maybe some types of examples that you haven't seen before. I will see you guys soon.